So we were talking about L'Hopital's rule today. There were two mathematicians. The Swiss mathematician Bernoulli, he did all of this work and discovered this new rule, right? But he didn't get the credit for it. L'Hopital was the first to publish it, and so that kind of stinks, right? You do all of this genius mathematical work, and then you don't even get the rule named after you. So, number one, they have the best hairdos ever, right? Number two, which one of these people, based on what I just said, do you think is L'Hopital and which one is Bernoulli? I agree, right? With that little mischievous grin there. And Bernoulli, he's just kind of sad because it's not Bernoulli's rule, right? It's L'Hopital's rule. So here we go. Here's what it says. Well, that is unfortunate right there. Give me 1 second. And we are back in business. Okay, so here's what L'Hopital's rule says. If we have the limit as x approaches a certain point, and I've got f of x over g of x, and I plug that value a in, and I get an indeterminate form. By indeterminate form, I mean 0 over 0 or positive infinity over positive infinity. Then what I can do to evaluate the limit is take the derivative of the numerator, and then take the derivative of the denominator and then reevaluate the limit. So let me give an example. Some of these you can work out using algebra like we did before when we did limits, but not all of them. So if I take the limit as x approaches 2 and I plug in 2, I'm going to get 4 minus 4 in the numerator and then 2 times 0 in the denominator, which ends up being 0 over 0, which is an indeterminate form. So if you were doing a multiple choice question, then you don't need to do this. Just work it out and solve it, right, and get the right answer. However, if you're doing a free response question, you need to demonstrate that it is an indeterminate form so that L'Hopital's rule applies. It's kind of like the mean value theorem. If you get a mean value theorem on a free response question, you've got to say, since the function is continuous and differentiable, therefore the mean value theorem applies. It's the same thing here. I need to show that it's an indeterminate form. Therefore, L'Hopital's rule applies. This would be for a free response question. Okay, which this is not, right? But I'm showing you this so that you will know to do it if you get a free response question. So once I get the indeterminate form, 0 over 0, L'Hopital's rule says that I'm going to take the derivative of the numerator. So I've got the limit as x approaches 2. The derivative of x squared minus 4 is 2x. The derivative of the denominator would be derivative of 2x is 2. And now I'm going to reevaluate the limit. So I take 2 and plug it in, which gives me 4 over 2. So the value of this limit is 2. And again, I could have gotten this one using algebra, but not really for the next one, for example. Okay, so for the next one, I have the limit as x goes to 0 of sine of x over x. If I plug in 0, I get sine of 0 over 0. And the sine of 0 is? It's 0. So I've got 0 over 0, which is an indeterminate form. Therefore, L'Hopital's rule applies. So I'm going to reevaluate after taking the derivative. Derivative of sine of x is cosine of x. And the derivative of x is 1. So notice I don't do the quotient rule here. I take the derivative of the numerator and the derivative of the denominator. And now I'm going to reevaluate the limit. So I take 0 and plug it in, which gives me the cosine of 0 over 1. And the cosine of 0 is 1. So the value of this limit is 1. All right, well, let's look at another one. I have the limit as x approaches 4. So I'm going to plug in 4, and let's see, that will give me 48 minus 48 in the numerator, and 16 minus 16 in the denominator, which is 0 over 0. Therefore, it's an indeterminate form. So I'm going to take the derivative. I have the limit as x approaches 4. Derivative of the numerator would be 6x minus 12. And the derivative of the denominator would be 2x minus 3. And now I'm going to reevaluate the limit by plugging in 4. So that's going to give me 24 minus 12, which is 12. And I plug in 4 here. 8 minus 3 gives me 5. So the value of the limit is 12 over 5. Okay, why don't you try number 4 and number 5 for me? Do that right now. And check with your friendly calculus neighbor there to see how he or she is doing. So in number 4, I plug in 0 and I get e to the 0 minus 1 over 0, and e to the 0, anything raised to the 0 power is going to be 1. Therefore, I get 0 over 0. And so I'm going to take the derivative and reevaluate. The derivative of e to the 3x is e to the 3x times 3. And in my denominator, careful, okay, I saw lots of mistakes this morning. The derivative of x is not 0, but it's 1, right? And so now I'm going to plug in 0. And so when I plug in 0, I will get 3e raised to the 0 over 1, and e to the 0 is 1. Therefore, the value of this limit is 3. Okay, and the last one here, quickly, if I plug in -1, I'm going to get 2 minus 2 over -1 plus 1, which is 0 over 0. And so I'm going to take the derivative. That's going to give me 4x over 1. And this is the limit as x approaches -1. I plug in -1. Should be -4. Okay, so let me stop there for a second. Any questions so far over L'Hopital's rule? All right, I want to do 2 more multiple choice questions, okay? These are from previous AP exams. So look at the next page on the guided practice there, and let's look at this. It's the limit as x goes to 0 of e to the x minus cosine of x minus 2x over x squared minus 2x. So if I plug in 0, I have e to the 0 minus the cosine of 0 minus 0 over 0 minus 0. E to the 0 is 1. Cosine of 0 is also 1. Therefore, I have 1 minus 1 minus 0, and so it ends up being 0 over 0. And so L'Hopital's rule applies. Sometimes you also see that written with an S, L hospital. So I could, give you fine people a bad joke here, but I'm not going to do that today. I'm just going to move on. L'Hopital's rule applies, so I need to take the derivative. Derivative of e to the x is e to the x. Derivative of negative cosine of x is positive sine of x, right? Derivative of cosine is negative sine, so I got a negative sign. So plus sine of x. Derivative of negative 2x is negative 2. And then in the denominator, I'll have 2x minus 2. So now I'm going to reevaluate the limit as x goes to 0. Plugging in 0 here, I have e to the 0 plus sine of 0 minus 2 over 0 minus 2. E to the 0 is 1. Sine of 0 is 0. So I've got 1 minus 2, which is negative 1 over negative 2. So the correct answer for this one would be positive 1/2. Why don't you try the next one? Are you with me? Okay. Try the next one for me, and it is a little tricky. So bring your calculus A game. It's the limit as theta approaches 0 of 1 minus cosine of theta over 2 sine squared of theta. Okay, so let's take a look at this. If I plug in 0, I'm going to get 1 minus the cosine of 0, which is 1 minus 1. So that's 0. If I plug in here, I'm also going to get 0. So I have an indeterminate form, 0 over 0. L'Hopital's rule applies. And so I'm going to take the derivative. So derivative of 1 is 0. The derivative of negative cosine of theta is positive sine of theta. And then when I take the derivative of the denominator, I need to use my good friend number 3, the chain rule. I can write this as 2 sine of theta squared. So let's do the chain rule. I got 2 times 2, which gives me 4. The sine of theta comes down. And then I multiply by the derivative of sine of theta, which is cosine of theta. So I'm left with this right here. And so now, look, if I plug in 0, I'm going to get 0 over 0. So 2 ways, the long way and the short way. The long way, if I have 0 over 0, it's an indeterminate form, and I could do L'Hopital's rule again, right? So I could do that, or what about this? What's the shortcut? The sine of thetas will cancel, right? And I'm left with a 1. So then I plug in 0. The cosine of 0 is 1, and I'm left with 1/4. So the correct answer is 1/4. Okay, so that is L'Hopital's rule. You need to finish number 6, the 2 multiple choice questions there, and then there's a couple of more guided practice problems on there. But right now, we need to do a little bit more notes. It's a 2-for-1 day in calculus, right? So let's look at IVT. So I'm going to skip ahead in my notes to the intermediate value theorem for continuous functions. So we've got the mean value theorem, which says if a function is continuous and differentiable, then the well, I had such high hopes for third period. I'm sorry. Okay, so if a function is continuous and differentiable, then the average rate of change is equal to the instantaneous rate of change if it's continuous and differentiable on the interval. Okay, we have the extreme value theorem, EVT, which says if a function is closed and continuous on an interval, then it must have a maximum and it must have a minimum. So now we have IVT, and really in the past I didn't even really teach IVT because it's kind of common sense, but you might get a question over it that maybe is not that straightforward. So let's take a look at it. So here's what the intermediate value theorem says. A function y is equal to f of x that is continuous on a closed interval takes on every value between those endpoints. So basically it says this. Let's say I have a function that goes from here to here. This is 1 and this is 8. Well, if I have a continuous function and it goes from 1 to 8, then it has to go through every point in between. So it has to go through 5, and it has to go through 6, and it has to go through 2.5. Okay? That's it. That's what the IVT says. It's also true for the derivatives. If a and b are any 2 points on an interval in which my function is differentiable, then the derivative takes on every value between f prime of a and f prime of b. Okay, so let's look at some AP problems that apply the intermediate value theorem. So example 1. Let f be a function that is continuous on the closed interval from 2 to 4 with f of 2 equal to 10 and f of 4 equal to 20. Which of the following is guaranteed by the intermediate value theorem? So I think it's helpful if we graph the information that they give us. So we've got f of 2 is equal to 10. So I've got a point right here. And then f of 4 is equal to 20. And so I don't know what my function looks like between these 2 points. I know that these 2 points are defined, and I know I have a function that is continuous. So I don't know, maybe it does something like that. So let's look at the answer choices. F of x is equal to 13 has at least one solution in the open interval from 2 to 4. Well, this is the correct answer. Okay, so let me explain why it's the correct answer and the others are not. This is saying if I have a function that's defined from this point to this point and it's continuous, does it have to go through 13 at some point? The answer is yes. Okay, because of the intermediate value theorem. My function's continuous. It goes from here to here. from 10 to 20. Therefore, at some point, it has to be equal to 13. So let's look at the wrong answer choices. This says if x is 3, y is 15. Does that have to be true? Well, it could be true, right? But it doesn't have to be. So that one's out. F attains a maximum on the open interval from 2 to 4. Well, that could be true also, but it does not have to be. Look at this right here. I don't have a maximum except at the endpoint, and this is the open interval, so this one's out. F prime of x is equal to 5 has at least one solution in the open interval. Oh, those little dirty College Board people are trying to get you to confuse MVT with IVT, right? That one's out because we're talking about IVT, not MVT. And my derivative is positive for all x in the open interval from 2 to 4. That could be true also, but doesn't have to be. Look, in this that I just drew there, it has a negative slope also, so that is out. Okay, we are going to look at one more example, then I'm going to give you some time to work on your homework here. Example 2 says, if a function f is continuous for all x, and if f has a relative maximum at -1, 4, and a relative minimum at 3, -2, which of the following statements must be true? So let's take a look at the graph. I've got -1 and 4, and I've got 3 and -2. So they tell me that this point here at -1, 4 is a relative maximum. And they tell me that this point right here at 3, -2 is a relative minimum. And I have a continuous function between the 2 points. So the graph of f has a point of inflection somewhere between -1 and 3. True or false? Doesn't have to, right? I could draw a straight line between this point and this point, and then it would not have a point of inflection. I mean, it could, right? It could change concavity, but does not have to. The derivative at -1 is equal to 0. Again, it is possible, but does not have to. Does it have to have a horizontal asymptote between those 2 points? No. Does the graph of f have a horizontal tangent at x is equal to 3? This one does not have to. The correct answer is E, okay, because of the the intermediate value theorem. If I have a function that goes from here to here, does it have to cross both axes? The answer is yes, okay? In other words, I cannot draw a function from this point to this point without crossing at some point both of the axes. Therefore, the correct answer is E.
That would be no work.
Well, this is saying that the derivative at -1 is 0. So look at what I just drew. At -1 is my slope 0. No. No. It could be, right? But it does not have to be. Okay.